Space, the final frontier, an endless expanse that stretches beyond our wildest imaginations. It's a realm of vast distances, mind-boggling phenomena, and breathtaking beauty, a place where the laws of physics are pushed to their limits, and where the wonders of the universe are on full display. It's a canvas upon which the universe paints its most spectacular masterpieces, each one more awe-inspiring than the last. From the birth and death of stars, where massive clouds of gas and dust coalesce to form new suns, to the cataclysmic explosions that signal the end of a star's life, to the collisions of galaxies, where entire star systems are thrown into chaos and new galaxies are born from the wreckage. In this vast cosmic ocean, we often find ourselves contemplating the profound mysteries that lie beyond our planet. What secrets does the universe hold? What is our place in the grand scheme of things? We yearn to understand the extraordinary events that unfold in the depths of space, events that challenge our understanding of reality and push the boundaries of what we know. Events so rare and awe-inspiring that they redefine our perception of the cosmos. These celestial phenomena are not just beautiful, they are windows into the fundamental workings of the universe. Join us as we journey through the cosmos to explore some of the most unbelievable events and phenomena that space has to offer. From the smallest particles to the largest structures, the universe is full of wonders waiting to be discovered. Brace yourselves as we delve into the heart of exploding stars, where the forces of nature are unleashed in a spectacular display of energy and light. Witness the cosmic ballet of celestial objects, as planets, moons, and comets dance through the void, each following its own path dictated by the gravitational pull of the stars. And unlock the secrets of the universe's most enigmatic entities, like black holes and neutron stars, where the laws of physics as we know them break down. Prepare to have your mind blown as we uncover the awe-inspiring wonders that make space so captivating. The universe is a place of infinite possibilities, and each discovery brings us one step closer to understanding the true nature of reality. Our journey begins with a cosmic dance of unimaginable scale, the collision of galaxies. These colossal events reshape galaxies over millions of years, creating new star systems and altering the course of cosmic history. These colossal events reshape galaxies over millions of years, leaving behind breathtaking remnants that illuminate the cosmos. The remnants of these collisions are a testament to the dynamic and ever-changing nature of the universe, leaving behind breathtaking remnants that illuminate the cosmos. Nebulae, the colorful clouds of gas and dust, are often the birthplaces of new stars, continuing the cycle of cosmic creation and destruction. From there, we'll travel to the remnants of dead stars, where the eerie glow of supernova tells tales of stellar demise and cosmic rebirth. These remnants, like neutron stars and pulsars, are the dense cores left behind after a star has exploded, where the eerie glow of supernovae tells tales of stellar demise and cosmic rebirth. These remnants are not just the end of a star's life, but the beginning of new cosmic phenomena, as the materials ejected from the explosion seed the formation of new stars and planets. Galaxies, those islands of stars scattered throughout the universe, may seem like eternal fixtures in the cosmic tapestry. These colossal structures, each containing billions or even trillions of stars, along with vast amounts of gas, dust, and dark matter, are the building blocks of the universe. They come in various shapes and sizes, from majestic spirals to massive ellipticals, and even irregular forms that defy easy classification. However, they are not immune to the forces of gravity. This invisible force, which governs the motion of celestial bodies, plays a crucial role in the life cycle of galaxies. It dictates their formation, evolution, and ultimate fate. Gravity pulls galaxies towards each other, setting the stage for interactions that can be both beautiful and violent. In fact, they often engage in a cosmic dance that can last for billions of years, sometimes leading to spectacular collisions. These interactions are not random. They are governed by the gravitational forces that each galaxy exerts on the other. Over time, these forces can pull galaxies into elaborate orbits, causing them to spiral towards each other in a slow, inevitable embrace. Imagine two vast collections of stars, gas, and dust, each containing billions of suns, hurtling towards each other at unimaginable speeds. The sheer scale of these events is mind-boggling. As they draw closer, the gravitational forces between them grow stronger, distorting their shapes and creating tidal forces that stretch and pull at their structures. The result is a cosmic ballet of epic proportions, a galactic merger. During this process, the galaxy's stars, gas, and dust interact in complex ways, creating new structures and triggering various astrophysical phenomena. The merging galaxies can form bridges of stars and gas, and their central black holes may eventually merge as well, releasing enormous amounts of energy. As galaxies collide, their gravitational forces intertwine, pulling stars, gas, and dust into intricate streams and tidal tails. These features can stretch for hundreds of thousands of light years, creating some of the most stunning and intricate patterns in the universe. The interaction can also funnel gas towards the galactic centers, feeding supermassive black holes and igniting quasars. These cosmic collisions trigger intense bursts of star formation, illuminating the merging galaxies with the brilliance of 1 trillion suns. The compression of gas clouds during the collision can lead to the rapid formation of new stars, some of which may be much more massive and luminous than our Sun. These starbursts can light up the galaxies, making them some of the brightest objects in the universe. The Milky Way itself bears the scars of past encounters with smaller galaxies, evidence of its dynamic history. These interactions have left behind streams of stars and other features that astronomers can study to learn about the Milky Way's past. By examining these remnants, scientists can piece together the story of our galaxy's growth and evolution, and it is currently on a collision course with our nearest galactic neighbor, Andromeda. This impending collision is a subject of great interest to astronomers, as it provides a unique opportunity to study the dynamics of galactic mergers up close. The Andromeda Galaxy, like the Milky Way, is a massive spiral galaxy, and their interaction will be a dramatic event. In about 4 billion years, our galaxy and Andromeda will engage in a gravitational tango that will forever alter the cosmic landscape. This event will unfold over millions of years, with the galaxies first passing through each other, then oscillating back and forth before finally settling into a new, merged configuration. The night sky, as seen from Earth, will change dramatically, with new constellations and celestial features. While individual stars are unlikely to collide directly due to the vast distances between them, the gravitational interactions will reshape both galaxies, eventually merging them into a single, larger elliptical galaxy. This new galaxy will have a different structure and appearance from either of its progenitors, with a more rounded shape and a less defined spiral structure. Witnessing such an event would be an awe-inspiring spectacle, a testament to the dynamic and ever-evolving nature of the cosmos. It reminds us that the universe is not static, but is constantly changing, driven by the fundamental forces of nature. These galactic collisions are a powerful demonstration of the scale and majesty of the universe, offering a glimpse into the processes that shape the cosmos over billions of years. Stars, like living beings, have a finite lifespan. They are born, they live, and eventually, they die. This life cycle of stars is a fundamental aspect of the universe, shaping the cosmos in profound ways. When massive stars exhaust their nuclear fuel, they die in spectacular explosions called supernovae. These explosions are among the most energetic events in the universe, marking the end of a star's life in a blaze of glory. These cosmic cataclysms briefly outshine entire galaxies, releasing an unimaginable amount of energy into space. The light from a supernova can be so intense that it can be seen across vast distances, even from other galaxies. What remains after this explosive death is a ghostly remnant, an expanding cloud of hot gas and dust illuminated by the fading light of the supernova. This remnant continues to glow for thousands of years, a haunting reminder of the star that once was. These supernova remnants, often taking on strange and beautiful shapes, serve as cosmic lighthouses, shining brightly in X-ray and radio wavelengths. The intricate patterns and vibrant colors of these remnants are a testament to the chaotic and violent nature of their origins. They act as cosmic particle accelerators, propelling particles to near the speed of light and influencing the evolution of galaxies. The high-energy particles generated by supernova remnants can travel vast distances, impacting the interstellar medium and contributing to the formation of new stars and planets. One of the most famous supernova remnants is the Crab Nebula, the expanding debris field of a star that exploded in 1054 AD. This explosion was so powerful that it was visible to the naked eye on Earth, even during the daytime. The Chinese and other ancient astronomers recorded this event as a guest star that appeared as bright as Venus in the daytime sky. These historical records provide valuable insights into the nature of supernovae and their impact on human history. Today, the Crab Nebula continues to expand and glow, a testament to the power of stellar death and the enduring legacy of stars. Its intricate filaments and vibrant colors are a constant reminder of the dynamic and ever-changing nature of the universe. The study of supernova remnants like the Crab Nebula helps astronomers understand the life cycles of stars and the processes that shape galaxies. While supernova remnants offer a glimpse into the aftermath of stellar death, other regions of space provide a window into the birth of stars. Within giant molecular clouds, vast and cold assemblies of gas and dust, gravity slowly draws matter inward. As these clouds collapse, they fragment into smaller, denser clumps, each with the potential to ignite into a star. Observing these stellar nurseries, such as the Orion Nebula or the Eagle Nebula, is like peering into the cosmic delivery room. We witness the raw materials of stars coalescing, heated by gravitational energy, until they reach the critical temperature and pressure necessary for nuclear fusion to begin. The birth of a star is a violent and chaotic process, yet it is essential for the creation of the elements that make up our universe, including the very atoms in our bodies. Within our own solar system, we occasionally witness rare and captivating events, such as planetary alignments. While not as dramatic as galactic collisions or supernova explosions, these alignments offer a unique celestial spectacle. Planetary alignment occurs when several planets appear in a line or a tight grouping in the night sky. While not perfectly aligned, these events provide a visual treat for skywatchers. One of the most remarkable planetary alignments in recent history occurred in 1982, when all 9 planets, including Pluto, which was still classified as a planet at the time, appeared within a 90-degree arc in the sky. Such alignments are relatively rare, occurring once every few decades or centuries, depending on the specific planets involved. These events remind us of the intricate dance of celestial objects within our solar system and the vastness of space that allows for such alignments to occur.